Cabinet Pro has a unique and valuable feature that allows cutlass and CNC machining to actually be independent of material thickness. Insets of one part into another can be independent of material thickness, and the width of dado cuts can be equal to the current thickness of whatever part is being inserted into it. This means that you can change not only the material, but also the material thickness of every single part in every cabinet and still rest assured that your cutlass and CNC machining will be accurate without any further adjustments. When used to process a real job, Cabinet Pro produces machining operations such as drilling operations, dado cuts, arcs, and more for each part of a cabinet. But to simplify our viewing of machining, we have eliminated all machining on all of our parts so that we can concentrate on just a couple of dado cuts, as is shown here. Also, we will use the same 1/4 inch tool for all cuts on our test part. What we have done is to create only 2 simple dado cuts for our unfinished ends. You will notice that we have made the width of each cut equal to the thickness of the part that is expected to be inserted into the dado. Here we have a dado cut where the cabinet's bottom will be inserted into it. So we have designated its width to be dependent upon whatever the thickness is of the material assigned to the cabinet bottom. And we have also made sure that the dado will always exist flush to the top of the toe kick. Our second dado is for the cabinet's back, which is currently 1/4 inch. Even though we have made the width of this dado cut equal to the back's thickness, notice that we want this dado to be slightly larger so that we don't have such a tight fit. So in actuality, this dado cut is 0.265 inches, which is the sum of these two values. Before we begin, let's inspect the shop drawing of a cabinet from this job made to the specifications of our sample construction method. Remember, Cabinet Pro allows a high degree of customization in how you build cabinets. What we are looking at is just one method of construction that can be modified to reflect the way you build your own cabinets. Notice the nailer is positioned on the outside of the cabinet's back. Looking at a top view of this cabinet, please pay special attention to the location of the cabinet's nailer, which butts up against the thin 1/4 inch back, while the top stretcher butts up against the inside of the 1/4 inch cabinet back. We will return to this drawing later when we change the thicknesses of our cabinet parts. But first, let's look at the cutlass and CNC output for our unfinished ends. This is a partial cut list for our entire job. You will notice that our unfinished ends are being made out of 3/4 inch fog gray, while our backs are being made out of 1/4 inch fog gray material. Let's now nest our parts to get them ready for CNC machining. Here we have optimized our job to produce 24 panels consisting of a number of different thicknesses of different kinds of material. By pressing the OK button, we will produce the CNC code for a machining of these panels, which can be seen visually by the CNC simulation of our 2 dado cuts for an unfinished end. You will notice the 1/4 inch wide cut for the back dado is a single pass represented by a single line, since we were using a tool with a 1/4 inch diameter. And the 3/4 inch wide cut for the bottom dado is performed with 3 passes represented by 3 lines, since we were using the same tool with a 1/4 inch diameter. Now let's make a global change of material and change all of our material to a panel whose thickness is 1 inch. Changing all of our material to an extra thick panel will make our changes very obvious. Now let's revisit that cabinet we looked at earlier. We will see that all parts are made of 1 inch stock, and changing this drawing to a see-through wire view will show all parts are made of the new 1 inch thick material. If we look at a top view again, we will see the positioning of the nailer, the back, and the stretcher remain the same as they were before, as do all other parts on this cabinet. And when we obtain a cutlass for the whole job, we see our entire cutlass coming out correct for 1 inch cherry. Of course, the correctness of each dimension shown here is not immediately obvious with a lot of calculations, but please be assured that they are correct. Our panel optimization is automatically correct also. We have more panels now than we had before, because remember that we changed all material to a 1 inch cherry, including some parts that were made of lumber before. And when we run our simulator, we will see our CNC machining has been automatically adjusted as well. Remember, we deleted all machining such as system holes, shelf holes, hinge plate holes, and numerous dado cuts so that we can concentrate on just 2 dado cuts that will demonstrate material independence. Note that the dado cuts have been adjusted to fit the parts going into them with multiple passes since we are still using the same 1/4 inch tool for both of them. Now let's use the same procedure as we used before and change the material to 1/4 inch stock. Remember, we are changing all of our parts to 1/4 inch thick material. Let's now return to our sample shop drawing. Again, looking at our shop drawing, we will see that all parts are being made out of 1/4 inch stock. All of the cabinets in this job have been adjusted as well. And once again, the positioning of our nailer, back, and stretcher is the same as it was before, as are all other parts on this cabinet. And our cut list has been automatically and appropriately adjusted as well, with the parts being different sizes than they were before because of the differences in insets. Our panel optimization has been automatically changed to the new 1/4 inch material, and we have fewer panels this time because the size of our panels have changed to be larger than the panels we were using for our 1 inch cherry. And our CNC machining has changed to match the new material as appropriate, with the same dado cuts we saw before being adjusted to fit the 1/4 inch parts going into them, represented here by a single line because each line represents one pass, and the tool that we're using is a 1/4 inch bit. In summary, Cabinet Pro allows you to change some or all of the material being used in your jobs for some or all of your cabinets in that job. When you change anything to a material of another thickness, you can rest assured that your cut list, bids, and CNC output will all be automatically adjusted with perfection. Cabinet Pro's manufacturing processing is designed to save you time because needless time spent on changing parameters on a computer converts to lost money very quickly, as well as mistakes. So Cabinet Pro is designed to have you spend as little time on your computer as is possible, thus minimizing mistakes and maximizing your profits.